Hello everyone, today I'm going to report LAPT number 4 problem, funnel and ball. Let's review the problem. A light ball, such as ping pong ball, can be picked up with a funnel by blowing air through it. Explain the phenomenon and investigate the relevant parameters. Here's my catalog. The first part is a preliminary experiment. The second part is my theory analysis. The third part is my experiment analysis. The fourth part is my error analysis, and the last one is my conclusion. This is a video of our preliminary experiment. We found that the ball is lifted up, and also the ball is fluctuating in the funnel. To explain this phenomenon, we decided to use the Bernoulli principles to help us explain it. And according to the Bernoulli principles, the P is times 1 over 2 rho v squared times rho gh is equal to a constant. And the air velocity in the funnel on the upper surface of the ball, the velocity of the airflow is higher, and the velocity of the bottom surface is lower, so that the low pressure caused by the high speed and the high pressure caused by the low speed cause the pressure difference between the bottom surface and the upper surface, so that the pressure difference causes the lift and lifts the ball up. Besides the pressure difference, also the air has an impact on the ball. And in the real case, the air moves through the ball. But we can transfer the motion to the ball moves in the air. Seeing the two motions are equivalent, so that we can analogize the impact to the air drag. And according to the equation of the air drag, Fd is equal to 1 over 2 CD A rho v squared. And the CD here is a drag coefficient, and the A here is a reference area. And the V here is a relative velocity. After figuring out all the force acting on the balls, an impact pointing downward and gravity pointing downward, and also a pressure difference pointing upward, we can calculate the net force of acting on the bubbles, which is equal to the pressure difference minus gravity minus drag force. And to find the velocity in the funnels, we first need some initial conditions. First, the cross section of the funnel and the initial velocity input to the funnel. And since the air is uncompressible in the funnels, so in every place the amount of airflow should be the same. So according to the continuity of the airflow, we can figure out the value of the V, so that we can find the value of the drag force and the pressure difference. But in fact, the airflow in the funnel is not like this. Also, the air in the funnel is compressible, so that the equation is not applicable. Also, the principal equation you can only use in the isentropic flow, so that all these two equations are not applicable. So then we need to use another equation called Navier-Stokes equation to explain this phenomenon on laminar flow level. And this is the Navier-Stokes equation. And the mu here is the dynamic viscosity. But after seeing this equation, we have two very important problems. First, how to calculate the velocity of the air. And second one is how to solve this equation. We find the answer in the computer simulations. We input the Navier-Stokes equation into the computer simulation software, and use the software to simulate the whole motion. And the theory behind the computer simulation is finite element analysis, which is to divide the whole model into many small parts, and each part has their own differential equation set. And the computer can use iterations to find the value answer of each equation, so that it can simulate the whole motion. And we can export the graph of the air velocities. And also we build a probe in our computer simulations to help us to integrate the pressure on the surface of the ball. And we can export the graph of pressure here. We can see that the pressure difference is always larger than the gravity, so that the balls will be lifted up. And the pressure difference here is including the pressure difference caused by the different air velocities and also the impact of the air. After finding the series, we begin our experiment. This is a video of our experiment. This is our experiment set. This is a blower. This is our funnel. And on the bottom, there is a support to support the ping pong ball. And there's a ruler to help us control the distance between the ping pong ball and the funnel. And in our experiment, we decided to change 4 parameters. First is the shape of funnels. And second is the mass of balls. The third is the velocity of the air. And the last one is the distance between the balls and the blower. In our experiment, we use 5 kinds of funnels, and we use vernier calipers to measure the parameters of the funnel. And we use the ping pong balls as a ball. And to change the mass of the ping pong ball, we inject hot glue in the ping pong balls from 3 grams to 5 grams. Also, to control the air velocity, we use 2 gears blowers. And we use hot glue to connect the funnels and the blower. And to measure the air velocity of the blowers, we use air velocity measuring machines in factory. And the amount of airflow of the first gear of the blower is equal to 1.058 cubic meter per minute. And the amount of airflow of the second gear of the blower is equal to the 2.18 cubic meter per minute. And according to this equation, the velocity of the air is equal to the amount of the air over the cross-section area. We can find the velocity of the air in the funnel. And also we use the ruler to control the distance between the center of the ping pong ball and the bottom of the funnel. And the figure shows that the distance between the ping pong balls and the funnels is equal to 0. And we control the type of the funnel and use the second gear of the blowers. We can export the form of a result. And the blue cells means that the ball can be lifted up. And the red cells means that the ball cannot be lifted up. According to the form, we can see that if the heavier ball is lifted, the lighter balls must be lifted. We can explain these conclusions by Newton's second law easily. And also we control the mass of the balls and use the second gear of the blower. We can export this form of result. And the blue cells means that the simulation shows that the ball cannot be lifted up, but the experiment shows that the ball can be lifted up. And the green cells here means that there's no data because, for example, for the type 1 funnels, the distance between the ping pong balls and the bottom of funnel cannot be minus 1 millimeter, so there's no data here. And we can see that if the ball can be lifted up at a certain distance, it must be lifted up at a shortened distance. To find the reason behind it, we compare the simulations when the distance is equal to minus 50 millimeters and the distance is equal to 30 millimeters. We found that when the distance is equal to 50 millimeters, the air velocity on the upper surface is higher, and the air velocity on the bottom surface is lower. But when the distance is equal to minus 30 millimeters, the air velocity on the upper surface is lower, and the air velocity on the bottom surface is higher. So that the pressure difference on the left side is much bigger than that of the right side, so that the ball with the shorter distance between the funnel can be lifted up more easily. Also, in our experiment, we find 2 kinds of fluctuation. First is the ball is fluctuating in the funnel, and the second is that the ball is lifted up and hits the blowers and rebounds. We explored the graph of the pressure difference, and we found that actually the pressure is fluctuating. And also we can see that the pressure is always larger than the gravity, so that the balls will hit the blowers and rebounds. But there is still some error in our experiment. First, actually the airflow in the funnel is the turbulent flow instead of the laminar flow. But we simulate the whole motion in the laminar flow physics, so that there's a little errors. But according to the graph, we found that there's no significant difference between the 2 graphs. But the solving time of the laminar flow physics is only 9 seconds, but the time for the turbulent flow is 10 hours. So compared to the solving time, we decided to use the laminar flow as our theory. And also there are some major errors in our experiment. First is the Vernier caliper accuracy is 0.01 millimeter. And the amount of airflow accuracy is equal to 0.01 cubic meter per minute. And the distance accuracy between the center of the ping pong ball and the bottom of funnel is equal to 1 millimeter. And the max accuracy is 0.1 grams. And the last one is my conclusion. First, the higher airspeed, smaller mass, smaller distance between the blowers and center of balls allows the balls to be lifted up more easily. And the turbulent flow indeed influences the pressure on the ball, but turbulent flows and laminar flows has no significant difference. So the Navier-Stokes equation is enough to explain this phenomenon. And this is my reference.